All right, everybody, welcome back. Today, I'm going to be doing a video on graphing exponential functions and understanding what the graph and the equation is telling us. So today we are graphing exponential functions. And we're going to start with one of the most basic functions. I'm going to start with f of x is equal to 2 to the x. So in order for me to do this function, I'm going to start off with a table of values. So remember, my left is always my inputs. X is the variable associated with inputs. F of x is my outputs, so that's always on the right. So in order for me to do this, I'm going to look for a couple of values, and I'm going to see how this graph looks. I'm going to start with -3, -2, -1, 0, 1, 2, and 3. So I'm going to start off with f of -3. So look, what I'm going to do is here is my function equation. My input is -3. So what I'm going to do is I'm going to go f of -3 equals 2 to the -3. Notice that I put my input wherever there was an x. So now I'm going to simplify this. This is just a label. This is not telling me multiply f with -3. No, 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 no. This is just telling me the output for when the input is -3 is going to be whatever's over here. So I'm only going to simplify this side. So notice here I have 2 to the -3, which means I have an exponent here of negative power. So if you remember my exponent video, I do have positive flip here, which means I have 1 over 2 to the +3. In order to take this negative power and turn it positive power, I have to take the reciprocal of the base. So the base is 2, which is really 2 over 1. The reciprocal of that is 1/2. So this is what I have. And then this is going to simplify to 1 over 8, because 2 to the third is 2 times 2, which is 4, times 2 is 8. So on here I have 1/8. Cool? So now I'm going to do the same thing. I'm going to do f of -2. Say that next one here. So now f of -2 is going to be 2 to the -2, which means 1 over 2 squared. There's my positive flip. And 2 squared gives me 1/4. So I hope you can see that I'm still building a pattern here. So f of -1. So again, f of -1 gives me 2 to the -1, which again, positive flip is just 1/2. So this is 1/2. And notice how important it is to understand those exponent rules, because here I go, watch this one. F of 0 is equal to 2 to the 0. 0, 1 rule says that any base or any exponent to the 0 power will always give me 1. So I know that f of 0 is equal to 1. And this point right here is really important, because since every single, Diego, sorry guys, my kids are here too. So, multitasking. Right there, the pink box. Thank you, babe. Any value, any f of 0, this is the the y-intercept right here. So I know that f of 0 is 1. This right here is my y-intercept, right? And this is my anchor point. So this is going to be called my anchor point, because you're going to see something that I'm going to show you in a little bit. So this is my anchor point right here, okay? So remember that. So I'm going to put a little estrellita here, because this point is really important right there, okay? So now, moving on, I don't think I have to explain the rest, because the rest, if you notice, I have f of 1 equals 2 to the 1. Well, that just means that f of 1 equals 2, right there. 2 squared. F of 2 equals 2 squared. Well, that means that I have 2 squared is 4. See that? And f of 3 equals 2 to the third power, which is 8. So I hope that you can also see that my positive flip rule is present here with all of the, with just the table of values. If you notice, 3 corresponds to 8, just the same way that -3 corresponds to 1/8. So you see the positive flip rule here, also on the table of values. Okay, so now we're going to go ahead and we're going to graph it. So these are my points, and I'm going to graph it. Here is going to be my graph. Notice I'm also going to graph another function here on top of it so we understand how to read the equations for these graphs. Okay, 2, 4. I always label my graphs. You should too. Okay. Okay. So this function, I'm going to graph it in a, hold on, okay, in a red color. So this function is going to be in red. So let's start with the easiest point, which is my anchor point. 0 corresponds to 1. It's right here. That point is my anchor point, okay? And then I have 1 corresponds to 2 right there. 2 corresponds to 4. Notice it's already curving. 3 corresponds to 8, okay? -1 corresponds to 1/2. -2 corresponds to 1/4. And -3 corresponds to 1/8. So if I want to go ahead and look at this function, here is my function. Let's look at this. This is my exponent function. And let's look at it. There is a horizontal asymptote. We recognize or remember what an asymptote is. An asymptote is a boundary. It's an imaginary line that I'm placing on my graph that's indicating to me that this graph will always infinitely approach it but never reach it, okay? So let's go look at a couple of things of properties of f of x equals 2 to the x. So look at some properties of this function. So we know that it has a horizontal asymptote where at y equals 0. So this right here is my horizontal asymptote. And what does this mean? This is end behavior. Oh, sorry. Let me bring it up. There we go. Okay. What does this mean? This means that my end behavior, okay, so I have end behavior. And end behavior is how is this function behaving in its extreme value? So that arrow means as my inputs reach -infinity, my outputs are doing something as well. So if, remember, let's look at it. As my inputs are going to -infinity, my outputs are infinitely approaching this line but will never reach it. So watch how I'm going to write this. As x approaches -infinity, f of x is approaching 0. It won't reach it, but it's approaching it, okay? And then let's look at how is it behaving as x approaches +infinity. So as x approaches +infinity, we can see that. So as x approaches +infinity, our outputs are also approaching +infinity. So that's really important for my end behavior. And this end behavior is attached and related to this horizontal asymptote, right? Okay, so now let's go ahead and see what is going to be our domain and range. And domain and range is so important because it also gives us a way to analyze the behavior of this function. So domain, let me bring it up. Okay, there we go. Color it. Put some pictures and put some names on there. Go ahead. My domain is always going to be inputs. Domain is associated with inputs. And I have, what's happening here? How's my inputs behaving? Well, my minimum most input is -infinity, and my positive most input, or my largest input, because that arrow, let me put it there. There we go. That arrow is going to infinity, which means that my inputs are also going to infinity. So my domain is always going to be -infinity to infinity, because non-inclusive, of course, infinity can never be inclusive. It's still growing, okay? And then let's look at our range. Let's go back to our graph here. My range goes from, what's my most minimum output? Well, remember we said that this is a horizontal asymptote, which means that it's infinitely approaching it, but will never reach this output. What is the output at this line? Yes, it's 0. So it's going to be non-inclusive 0. So my range is f of x such that non-inclusive 0 to infinity. Okay? I must erase all of this because I need the space, but just a couple of features. So again, I'm putting this here. Okay, so we recognize domain and range. We also see that it's always increasing, and you can see that from my end behavior analysis. Okay, so I'm going to leave that just like that. And I'm going to now graph another one. So I'm just going to put on here, this right here is f of x equals 2 to the x. What happens if I now graph another one? I want to graph, let's see, I'm going to graph g of x equals 2 to the x minus 4. Wow. Well, let's see. Remember, if we don't know how this function is occurring, we can always make a table of values, right? So I'm going to go ahead and put -3, -2, -1, 0, 1, 2, and 3. And we're going to see what happens. So let's start with g of 0, because remember, g of 0 is my most basic input and output here. So remember, g of 0 means that I have, so here's my function equation again, 2 to the x minus 4. If I'm going to look for g of 0, wherever there was an x, I'm replacing it with the 0. So 2 to the 0 minus 4. Again, 2 to the 0 by 0, 1 rule says 1 minus 4 gives me -3. So I know that this is -3 here. Cool? Let's look at g of 1 now. So g of 1 equals 2 to the 1 minus 4, which is 2 minus 4 gives me -2. Wow. Okay. And then let's do g of 2 now. Sorry, let me get my little paper. There we go. Okay. So I have g of 2 gives me 2 to the second power minus 4, while 2 to the second power is 4 minus 4. That gives me 0. And then g of 3 is 2 to the third minus 4, which is 8 minus 4, which is 4. Okay? And then let's do the fractions. Don't get us scared because we're going to have a little fraction on here. It's okay. So let's see. Let's start with g of -1. G of -1 is 2 to the -1 minus 4. We recognize that 1 to the -1 is 1/2 minus 4. So remember, that's 4 over 1. If you don't understand how to simplify this, go back and look at my fraction 1, right? My common denominator, here's my little plump station, yes? Let me, yeah. So my plump station, I have 1/2 and I have 4 over 1. Let me put this up a little bit so you can see. Okay. And I remember that my common denominator is going to be 4. So I need to change that to a 4, or actually 2, my bad. Here we go. My common denominator is going to be 2. So I got to change that to a 2 and that to a 2. So let's go ahead and see. Let me see if I can raise this up. Okay, here we go. So 1 times what gives me 2? Right there. 1 times 2 gives me 2. What I do to the bottom, I do to the top. Bam, that gives me 8/2. 8 divided by 2 is 4, which checks out. 2 times 1 gives me 2, so that's going to really just stay as 1/2. But it's good to still do the consistent process through the plump rule. So I now have 1/2 minus 8/2. What's 1 minus 8? That's now a numerator only analysis right there, because I now have a common denominator. And that gives me -7 over 2. -7 over 2 is the same as -3 and 1/2. Okay? So I'm going to put it right here. -3 and 1/2. Okay. Let's go ahead and do the next one. So I hope you saw that. If you need help with fractions, go back and look at my fraction video and then come back and revisit this video because you'll be able to do it. Okay, let's do g of -2 now. So g of -2, sorry about that, is 2 to the -2 minus 4, which gives me 1/4 minus 4. Now I have a common denominator of 4. So this is going to be 1/4 minus 16/4, which gives me negative 15/4. And negative 15/4 is negative negative 3 1/4. So negative 3 1/4, and 3 1/4. Remember, hold on, 3/4. My bad. 3. Boom, boom, right there. So 4 times 3 is 12, plus 3 is 15. So right there, okay? And moving on to g of negative 3 gives me 2 to the negative 3 minus 4. Remember, this guy's positive and this guy's negative, so my answer is going to be negative since this guy is a larger value than this guy. So I have 1/8 take away 4. Okay? So that's going to be, again, 1/8. How can I turn this 4 over 1 into 8s? 32. 32 eighths, because 32 divided by 8 is 4, yeah? So this gives me negative 31 over 8, which is negative 3 7/8. Let's see, 8 times 3 is 24, plus 7, 31, right there. So I have negative 3 7/8. So just by noticing here, I'm going back. Let me see if I can go back to my bloop bloop. There we go. Okay. And going back to my table of values, here I am. If you notice something, where are these values approaching? So those values are all getting really close to negative 4, but they're never reaching it. So I now recognize that this guy has a horizontal asymptote at y equals negative 4. Because look, this started at negative 3.5, then this started at negative 3 3/4. This is going to go to negative 3 7/8. The next one is probably going to do, I don't know, negative 3 15/16. So if you notice, there's a pattern. So let's see. There is my horizontal asymptote for that guy. And I'm going to graph that guy in green. Okay? So let's see what we get. 3 corresponds to 4. So 3 corresponds to 4. Okay. 2 corresponds to 0. 1 corresponds to negative 2. 0 corresponds to negative 3. Negative 1 corresponds to negative 3.5. Bap. Negative 2 corresponds to negative 3 3/4, right there. Negative 3 corresponds to negative 3 7/8. So here it is. Bloop, 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 bloop. Okay, so if you notice, let me erase that right there. Okay, if you notice, what happened here? Let's look at the comparison between these two graphs. This graph and this graph are exactly 4 units away. Every single point is 4 units down. So what happened? This homie right here, this -4 right here, is telling me I have a vertical translation 4 units down. I have a vertical translation 4 units down. Okay, so I'm going to go ahead and erase all this. I'm going to go ahead and just put back my parent function f of x equals 2 to the x because I'm not done. Remember, you can pause and look at all these videos. So now I'm going to go back and redraw just my parent function because I'm going to go ahead and do right here. Okay, so 2, 4, 6, 8, 10, negative 2, negative 4, negative 6, negative 8, 2, 4, 6, 8, negative 2, negative 4. Okay, so I'm going to go ahead and graph just my basic function, which again, 0 corresponds to 2. Again, I'm graphing my parent function. We'll call it P of X. That's what I make my students call it. P of X 2 to the X. Okay, so 1 corresponds to 2, 2 corresponds to 4, 3 corresponds to 8, and negative 1 corresponds to 1/2, 1/4, 1/8, and so forth. So, there is my parent function. This is 2 to the X right here. Now watch, I'm going to go ahead and graph now. Let's see. H of X equals 2 to the X plus 3. So remember, the other one had a vertical translation 4 units down because it had -4, right? Now this one has plus 3. Well, you know, when in doubt, you always make a table of values. Bum, bum, bum. This is going to be my H of X now. And let's see. 2 to the 0. 2 to the 0 is 1 plus 3 gives me 4. Let's see H of 1. So watch, this is what I'm doing. I have 2 to the X plus 3. H of 1, that's my input. Wherever there's an X, I'm now putting that on there. So that gives me 2. 2 to the 1 is 2, plus 3 gives me 5. So I know that H of 1 corresponds to 5. Whenever I have an input of 1, my output is 5 right there. See that? Okay, let's do another one. Let's look at H of negative 1. So that gives me 2 to the negative 1 plus 3. That gives me 1/2 plus 3. That gives me 3.5. Okay, 3.5. Okay, and then let's go ahead and see negative 2. So negative 2, H of negative 2 gives me 2 to the negative 2 plus 3. This gives me 1/4 plus 3, 3.25. You see something? I'm slowly approaching that 3 again. So I know that this guy has a horizontal asymptote at y equals 3, positive 3 this time. Okay, let's see what H of 2 gives me. H of 2 is 2 squared, which is 4, plus 3 gives me 7. Okay, so now I'm going to go ahead and graph that guy. And we're going to go say and see what's up. So I have 0 corresponds to 4. Bum, 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 right there. 1 corresponds to 5. 2 corresponds to 7. Negative 1 corresponds to 3.5. So, and I recognize that I do have a horizontal asymptote. I'll do my horizontal asymptote at y equals 3. So, remember, it's an imaginary line that this graph will never cross. And here is my graph of H of X equals 2 to the X plus 3. Okay, so what do you think happened here? This is another vertical translation. How many units and in what direction? Remember, translation means I move in a northwest, south, east direction. So I have to give you very specifics. Vertical translation means up or down, and now you have to tell me how many units and in what direction. So the plus 3 here says 3 units up. So tell me if it makes sense that I take my original function 2 to the X, and by adding this plus 3 on the outside of the function, all I really did is I shifted it up 1, 2, 3 units, and bam, I got to my green one. Yes? Okay. So far, so good. I hope you are. Please help me comment on there if you have any questions, if you need me to clarify anything. If you're watching this, thank you so much. So again, now we know vertical translation. So let's look and see. If my function looks like this, right there, so far, we recognize that this homie right here gives us vertical translation. Okay, if it's positive, it means up. So this one was positive, so it means 3 units up, bum, bum, bum. If it's negative, in the previous example, I had -4, so that means 4 units down. Okay, so let's move on to the next one. Bum, bum, bum. So now, again, I'm going to regraph my original function. 2 to the x, that's always been my go-to. Okay, so notice that I do take my time in making sure that my graph has all of my points on there. Okay. -2, -4, and it's labeled. I'm going to go ahead and put my basic parent function on there. So 0 corresponds to 1, 1 corresponds to 2, 2 corresponds to 4, 3 corresponds to 8, -1 corresponds to 1/2, -2 corresponds to 1/4. So again, here's my 2 to the x, still right there, right? That's my homie, that's my parent function, that's the one that I always compare against. So now I'm going to go ahead and do, we'll call this m of x is equal to 2 to the x plus 4. What do you notice now? I hope you notice that in my previous examples, the change that I added to my equation was on the outside. It was never in the power. Right now, I've now messed with my power. Remember, my power is the input, right? So I'm now messing with my x variable, not with the output. So let's go ahead and make a table of values and see what we have. So I have x and m of x. So again, we'll do -2. Let's do -3, -2, -1, 0, and we'll start and 1. Okay? So let's see. I'm going to write my function. M of x is equal to 2 to the x plus 4. Let's see. M of -3. Remember, whenever I plug in a -3 here, that means I'm replacing the x value with whatever value I'm putting in here, which is giving me 2 to the -3 plus 4. I simplify this first because notice there's parentheses there, so I'll put them here too. And that's going to give me -3 plus 4 is 2 to the 1, which is just 2. So m of -3 is 2. Okay. Let's look at m of -2. So m of -2 gives me 2 to the -2 plus 4. -2 plus 4 is 2, so 2 squared gives me 4. Okay, I hope you can see a pattern now. -1 plus 4, so let's see if we can do this now internally. -1, that's my new input, plus 4 gives me 3. 2 to the third power is 8. 0 plus 4 is 4. 2 to the fourth is 16. 1 plus 4 is 5. 2 to the 5 gives me 32. Okay, let's see how this looks. So we're going to go ahead and graph this now. So let's see. -3, boop, 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 corresponds to 2. -2 corresponds to 4. -1 corresponds to 8. And so forth. And then -4 is probably going to correspond to 1. -5 is going to correspond to 1/2. So what do you think is happening here? I want you to pay attention. Now the relationship is this way. So now there's this horizontal translation that happened here, right? Okay. So if you notice this function, and I'm going to go ahead and graph it now. Yep. Okay, if you notice, I now have a horizontal translation. So because I'm messing with my inputs, remember, this now here gives me a horizontal translation. But how many units did we move into what direction? I'm here. This is my original one. Did I move to the right or did I move to the left? I moved to the left. But wait, it says plus. Most important thing here is that horizontal translation will always be the opposite of what the equation tells you. Write that down. Again, horizontal translation is always opposite of what the equation tells you. My equation is telling me plus, so that really means horizontal translation. 4 units left, because it's always opposite. 4 units left. Okay? Bam. So, I'm going to go ahead and leave that there, and now I'm going to do, in green, I'm going to do the next one, and I'll do it right next so you can see what I mean. I have 2 to the, I'm going to do x minus 5, so we can make a thing. Remember, horizontal translation, I'm still messing with my inputs because it's over here, right? And now it's going to be a horizontal translation. What do you think it's going to be? This is going to be horizontal translation. How many units and in what direction? Horizontal means left and right, yes? 5 units right. Let's see if it's true, okay? So let's make a table of values for this guy. Boop, boop, boop. X, n of x. So we'll start with 5. Start with 10. So we're going to do 4, 5, 6, and then we'll do 10 just to see what we get. Okay? So let me move that up. Okay. So 4. 4 minus 5 is -1. 2 to the -1 is 1/2. Okay? 5 minus 5 is 0. 2 to the 0 is 1. 6 minus 5 is 1. 2 to the 1 is 2. 10 minus 5 is 5. Actually, let's put this at 8. Well, let's just do 7 and 8. We'll do like that. 7 minus 5 is 2. 2 to the 2 is 4. 8 minus 5. 8 minus 5 is 3. 2 to the 3 is 8. So let's go ahead and graph this guy and see if it's true. So at 4, I'm at half. At 5, I'm at 1. At 6, I'm at 2. At 7, I'm at 4. And at 8, I'm at 8. So, right there. And so here we go. So do you notice, again, we always compare against my 2 to the x. That's my parent function. I took that function. It's like me taking that 2 to the x and shifting it 5 units to the right. So I'm hoping that you can see now that when I look at a function, this is the formula, because this right here is my horizontal translation. And notice that my formula says minus. And that's important because it's always going to be, this right here says negative plus 4, which really means negative, negative. A negative minus gives me a plus. And notice I'm going left, okay? Horizontal translation. And this guy is vertical translation. Okay? So let's see if we can pinpoint some of these things now that we understand how this works. I'm going to go ahead and give a couple of examples, and I'm going to give you some thinking time, just like Dora the Explorer, and then I'll chime in on here. So it's on you to make sure we get this, okay? So let's say I have state the transformation. So far, the transformations that we know how to do are translations that are vertical and horizontal, and maybe both, okay? So let's do number 1. Let's say I have f of x equals 4 to the x minus 5, okay? And then this one, g of x is equal to 4 to the x plus 3, and h of x equals 4 to the x plus 7 minus 2. Okay, so again, let's go ahead and look and see what we have. I don't have anything up here because the variable is still by itself. So on all three of these, my parent function is 4 to the x. That's the one I'm always comparing against, right? So what happened to this one? This one, I have something on the outside of the input. It's not affecting this power here. So that's going to be 5 units down. Vertical translation, VT, vertical translation, 5 units down. That's all this one is right here. Let's look at this one. This one has no vertical translation because there's nothing on the outside. But this one here is horizontal. Remember again, golden rule. The horizontal translation is always opposite of what the equation is telling me. The equation is telling me +3, but it's opposite of that. So it's going to be horizontal translation, 3 units left. Right there. Cool? And now let's look at this one. This one has both of them. So this is right here. This one's going to give me horizontal translation is the only one that gives you opposite. Vertical translation is always as is, face value on the equation. So this one is going to be horizontal translation, 7 units left, 7 units to the left, and vertical translation, 2 units down. So now watch how easy it's going to be for me to graph these because I'm able to do them super fast. I'm going to just do a quick sketch, okay? So this is a sketch just to give you a review of what I'm doing. So my parent function is going to be right here in black. P of x, 0 corresponds to 1, 1 corresponds to 4, 2 corresponds to 16, right? So there is my function right there. This right here is 4 to the x. That's the mother, that's the parent function. That's the one that I compare against always. Here I'm going to do f of x is going to be in green. I know it's going to be this function just shifted down 5. Okay, 1. And no, I'm going to use my anchor point. My anchor point is the most important point because it's the one that has, it's an integer number. So I have go down 1, 2, 3, 4, 5. So right there. And now everything else is going to just be in that manner. So bloop, bam. I just graphed f of x right here, which is just vertical translation 5 down. Okay, now I'm going to do g of x. Bum, bum, bum. G of x is going to be in blue. And that means horizontal translation 3. Again, I'm going to take that anchor point because I'm always going against my parent function. And I'm going to graph it 3 units to the left. So now that's my new anchor point. And whoop, right there. G of x is right there. Cool. And I just graphed it because I knew the equation told me how to do it. I know how the parent function looks, and I'm good to go. And my last one, h of x, bum, 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 right there. H of x says horizontal 7 to the left and 2 down. So again, I'm going to take this anchor point, and I'm going to go 7 to the left, 1, 2, 3, 4, 5, 6, 7 to the left, and then 2 down. Bum, 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 1, 2. And now here's my function, whoop, right there. Look at how fast I was able to do a quick sketch of all these functions because I knew how to read the equation. So this right here is function translation for exponential functions. I hope you enjoyed it. Give me some feedback, do some digital reflections on my website for me. Thanks, guys. See you soon.
You're done?